Hello everyone, welcome back. In this video, we will talk about different switches and how to interface those switch with Arduino. So let's get started. In the slide, you can see there are different types of switch available in the market for using in your project. Like there is one type called SPST. The full form is single pole, single throw. And the switches are like this. Then we have SPDT, single pole double throw. The switches are like this. We have DPST, double pole single throw, and DPDT, double pole double throw. These are different types of switch. Other than this, there is also a switch called deep type of switch, which has a rack of switch, and you can use them in your different projects for switching multiple loads or multiple components. In this video, we'll basically take this type of switch, that is a push switch, and we'll try to understand how we can interface this type of switch with Arduino. So the internal structure of push switch, it has 4 legs. The upper 2 legs, that is A and B, these are connected between themselves, and C and D are connected between themselves. So when we press this button, it will make a contact between AB plate to CD plate. Otherwise, if you release the button, it will pop up and open the circuit. So this is basically a push switch. It will not keep stuck if you press this. As soon as you release the button, it will pop up and disconnect the connection. When we are dealing with this type of push switch, we need to use some specific configuration for Arduino to use this switch as an input. Here we can see 2 circuits. On the left hand side, there is a circuit with a power source VCC. Then we have a resistance in series with a switch, and finally ground. Above the switch, after the resistance, we have taken an output and fed the output to the Arduino 2 number pin, that is digital input pin. In the similar manner, on the right hand side, we have the same circuit, but the difference is on the left hand side, the circuit switch is open, and on the right hand side, the circuit switch is closed. Now let me explain what is happening here. If we build a circuit like this, when the switch is turned off, that is switch is open, then a power supply, that is VCC, a current will start flowing from VCC to resistance to the 2 number pin, which is a digital input pin for Arduino. The pin will read a positive supply, and it will take it as a logical 1 or high input. So when the switch is open, the Arduino will read high or 1. On the right hand side, the switch is closed for this case, and when the switch is closed, we can see the 2 number pin of Arduino, which is a digital input pin, it is directly connected to the ground. So it will read nothing but a 0 voltage level for this sort of configuration. As the ground is directly connected to 2 number pin, it will read 0 low. So these are 2 configurations of Arduino switch using this circuit. And the resistor we are using here, it is called a pull-up resistor. Why? Because when the switch is open, it is keeping the digital input pin 2 as always high. So that is why it is called pull-up resistor. If the resistance was connected to ground, then it would have been a pull-down resistor. Arduino has a built-in pull-up and pull-down resistor connected with this digital input pins. We will see that later. But for now, we will try this circuit and try to see if the switch operation can be detected using Arduino program. Before going ahead, I also want to introduce another concept related to switching, that is called debouncing. So what is debouncing? When we press or release a button, it can create a phenomena called bounce, where the electrical connections momentarily makes or breaks several times. So this is a problem because we are pressing one time, but due to the transients or due to the bouncing, it will read multiple on and off. So we can deal this sort of debouncing from hardware part as well as from software part. If you want to use software debouncing method, then adding a delay will be enough to reduce that effect. If you want to solve debouncing using hardware, then you can connect a capacitor across the switching terminal. It will remove the transients, or it will remove the debouncing. But for now, we will use the software delay. We will not show the capacitor method for handling debouncing for now. And another concept is related to push switch that we just mentioned, that is pull up and pull down resistor concept. So Arduino board have built-in pull up and pull down resistor, and to enable that pull up pull down resistor, we'll have to use the pin mode in a input pull up command. That is, the syntax will be pin mode, within the bracket we will use pin, then comma. Instead of input, we will have to use input pull up to enable the pull up resistor. So we'll see two demonstrations now. One without internal pull up, we will use external resistance as a pull up resistor, and then we will use the internal pull up. We'll see both demonstration. In the OQI, we will bring in VCC first to build up the circuit we just saw. Then we'll bring in another resistor. We'll connect the source with the resistor. We'll use push button for switching element. Remember that the upper two legs, these are connected between themselves, and the lower two, these are connected between themselves. So now from the second terminal, we will take a ground, and from the first terminal, we can also take from here. We'll read the switch status. Let's move it a little bit. Okay. You could have brought this line from this pin also. It doesn't matter. Anyway, now we have a VCC, we have a pull-up resistor, and if we do not press this switch, this 2 number pin, it will read the VCC and the resistor. So it will read a high voltage, that is 1. When we press this switch, the ground will be directly connected to this terminal, and it will read 0 volt. Let's see if we can program for this. So first of all, serial.begin. Then we will define using pin mode. The 2 number pin is our input. Then serial.print. In the serial.print, we will first introduce a message, and then we'll print the switch value, that is digital read. So it will read the status of the digital pin 2, and it will print side by side with this status. After that, for the next reading, we want to print a new line, serial.print, just bring in a escape sequence for new line. And to deal with debouncing, we'll add a delay here, delay of 100 millisecond. So I think that's all. So let's see if we can read the push switch status from this program. So as we have mentioned earlier, the switch, I haven't pressed it yet. That is why the pull-up resistor is giving a high value here, and it is reading 1. Once I press this switch, I have pressed this now, and it is giving us 0. Again, once I release it, it will give us 1. So this is how we can program for a push switch using external pull-up resistor. And accordingly, with this program, with this switch, you can also control a LED. Like if you press the switch, LED connected to 13 number pin, it will turn on. And if you lose the switch, that means if you release the switch, it will turn off. For that reason, we'll bring in the if-else conditions. So here's the syntax and structure for if-else condition. If you want to apply condition for any of your application, you can use if-else or switch statements. For if-else, there are several structures available, like you can use if with else, or if you have multiple condition, then you can use if, if, else. So how does this work? After if, in the first bracket, we put a condition here, if the condition is true, or if the condition value is 1, then it will enter this bracket and execute whatever written in here. If the condition is not true, or if it is not 1, then it will come to this else bracket statements and execute this ones. So this is pretty simple. For now, if and else is enough for the code we are looking for. In the upcoming video, maybe we'll try this structure and then I will explain it in more details. Let's see. If our digital read, that is 2 pin, if digital read 2, it is not pressed. Remember, if we do not press this switch, it will give 1. That is why the if condition statements will hold for not pressing the switch. So for that reason, we will turn off the LED, digital write 13 pin to low, and also we need to introduce the pin 13 as output, 13 as output, and else digital write 13 number to high. So with this block of if condition and else condition block, we can control the LED with the pressing of this switch. So let's see again. I haven't pressed the switch, so the LED is turned off. If I press the switch, you can see that LED is turned on. Release it, it will turn off. Press it, it will turn on. So this is how we can use external pull-up resistance with push switch to interface with Arduino. Now the second demonstration, where we will reduce this resistor and simplify the circuit using the internal pull-up resistor. So let me delete this thing. So in case of pull-up resistor, the circuit will be like this. In the first button, I will connect to ground, and the second button I will connect to 2 number pin. Now, if I do not press this switch, what will happen? No ground will be delivered to 2 number pin, but due to internal pull-up, it will remain high. But once I press this switch, it will connect the ground to this pin, and ground will be supplied to pin number 2. Then it will read low. So if we do not press this switch, it will read high. If I press this switch, it will read low. Pretty simple, right? And we have also reduced the resistance, and we have loosened another wiring to power supply. So to use this sort of configuration, you just need to come here and change this input to input pull-up. So once you do this input pull-up, it will make the 2 number pin always high until and unless you supply a ground. So let's see. The same program will now work for similar functionalities we just had in our previous demonstration. See, the LED is turned off. The switch start is 1 because it is internally high. Now if I press this switch, the ground is supplied to pin number 2. It will read low, and according to our program, the LED was on. Let me press it again. High. LED is turned on. It is reading low 0. If I release it, it is reading 1 and LED is turned on. So this is how we can use switch in 2 configuration using external pull-up resistance and using internal pull-up resistance. I hope this internal pull-up resistance is the simpler one, so we'll use it in our further programs. We will not increase the complexity of the circuit by introducing the resistance and additional wiring to power supply. We'll use this simple configuration with push switch. So that's all for this video. I hope you got the idea how to interface push switch with Arduino. See you in the next video. Thank you.